It's freaking hot. Let's do some AC repair videos. Hey, how's it going, do-it-yourselfers? So you guessed it, we're in the middle of another heat wave. So I thought, hey, what else better to do than to help people fix problems with their AC system? Now I got some questions here from my last video on how to repair problems with your AC system. And I'm going to try to answer these questions, and I'm going to give you some tips and advice on how to diagnose problems without using an AC manifold gauge set. However, there are some problems with your AC system that you simply do need to use an AC manifold gauge set, but if you watch this video, you'll learn some pretty neat diagnostic procedures that will allow you to fix problems with your AC system without a gauge set. All right, so without further ado, let's get to the questions. So the first question is from a subscriber named James Wan. James says, and I'm going to be paraphrasing and shortening the questions, that my compressor clutch is working, but once I turn on the AC, it gets overheated and the clutch dampener rubber has melted. Once the AC clutch is engaged, it does not disengage even when I turn the AC off, and it overheats. The clutch rotates properly, so I don't think the AC compressor is seized. All right, so basically the rubber or the plastic piece on your clutch disc, which on this AC compressor is going to be this piece right here. This is made out of rubber. It looks like metal, but it's actually rubber. All clutch discs have some sort of a rubber / plastic setup to work as a dampener for when the clutch engages and disengages the compressor. Now this has melted. Obviously there's excessive heat, like a lot of heat built up here, and something that has caused this rubber to melt. So there's a couple of ways this can happen. Now one way is that you have a seized AC compressor. One way to check if you have a seized AC compressor is to, with the car off, the engine off, you get down there to your AC compressor. Of course, here's your pulley. Your belt is on here with the engine off, AC not engaged. This is obviously not turning, so you get down there, you grab the clutch, clutch disc, I should say, and then you turn it, and if it turns, that means your AC compressor is not seized. Now, for those of you that don't know, this is basically how your AC compressor clutch system works. So you get your AC compressor shaft. This is this guy right here. This goes through your AC compressor. It's attached to the pistons that go up and down when your AC compressor is working and engaged. This is attached to the shaft like this, by the way of this 10mm bolt on this setup. And when the AC compressor is not working and not engaged, the belt turns the pulley and the pulley only. When you turn on your AC, there is a coil that looks like this, and this coil sits behind the pulley. Of course, it's not touching the pulley, it's attached to the compressor, but it sits right behind this pulley. So when the AC compressor is commanded on, this coil becomes energized, creates an electromagnetic field, and it pulls in on your AC compressor disc, clutch disc. And when this gets pulled in, it mates the disc and therefore the shaft with the pulley. So then everything turns together and your AC compressor starts compressing the refrigerant. All right, so if your compressor is seized, the pistons are stuck in their bores, and when you command the AC on and these two mate together and try to turn, since this clutch disc is attached to the shaft, and again the compressor is seized, when this mates with the pulley, this stays in place, and then the pulley turns and turns and turns, and this contact surface between the disc and the pulley overheats, it slips basically, overheats, and then that overheating issue will destroy the bearing that's in here, all the grease will come out, and also, of course, as you mentioned, it will destroy this rubber piece on your clutch disc as well. Now in this case, as James mentioned, the compressor is not seized, so what else can cause this? Another thing that can cause this snap ring that you can hopefully see that's around the shaft holding in the bearing, and therefore this pulley becoming loose or damaged for whatever reason. All right, so if that's the case and that's what's happening, then this, without that snap ring in place, this pulley and that bearing can start to slightly walk off this AC compressor housing. And when it starts to walk off, since the clutch disc is actually attached to the shaft, that stays in place, but then when this walks off, it closes down on the gap that's between the two usually, and then starts scraping against this clutch disc. That scrape, that friction will create a lot of heat that will definitely damage this rubber piece on your clutch disc. And of course, speaking of bearings, something else that can happen, that bearing can go bad itself, and when that goes bad and this pulley starts to have play, that play can again close the distance between these two. They can scrape against each other, create a lot of heat, and we'll be back to square one. Melted rubber piece on this clutch disc. All right, so those were mechanical issues that could cause you to have melted parts on your AC compressor, but there's an electrical side to this as well. There are electrical issues that can cause this. If you have too much resistance in your circuit to your AC compressor coil, whether it's corroded wires, corroded connectors, problem with your AC compressor clutch relay, the coil itself having too much resistance, all those can actually cause this to happen as well. Because if you have too much resistance, not enough amps are going to get to your coil. When you don't get enough amps, it doesn't pull this in all the way to engage the pulley. If it doesn't pull it in all the way, it's going to start slipping. And once it starts slipping, it's going to create heat. When you get heat, that's when rubber and plastic parts start to melt. The way you can diagnose this is fairly simple. If you know how to do a voltage drop test, that is. But basically, you want to do a voltage drop test from the power side of your coil for your AC compressor to your positive side of your battery. And you want to measure the voltage drop from the battery positive to the power side. This is, of course, with the coil engaged, because there has to be a load on the system in order to measure voltage drop. And you want to do it after this connector, because if you do it from up top, in this case, before the connector, you don't measure the voltage drop at the connector itself. So the connector has to be in here. AC clutch should engage when you turn the AC on. Then you do a voltage drop test from here to the positive side. And then, you shouldn't be more than let's say 4, 3, 4, 5 volts all the way from here to your positive side of the battery. If it's more than that, then that means there's too much resistance in the system from here to the positive side of your battery. And of course, you want to do a voltage drop test from the ground side of your coil to the negative side of your battery as well. And if you have only one wire going to your compressor, that's going to be your power. You can do a ground voltage drop test from the compressor body to the negative side of your battery. But also after that, you remove this connector and then you do a resistance measurement of your coil as well. Now this coil on here, I don't know what the spec for this is, but it has about 5 ohms of resistance, 4.5 ohms of resistance. Yours, of course, might be different depending on your car's manufacturer. But if you have too much resistance there, then that's obviously not going to allow enough amps to create a big enough electromagnetic field to pull the clutch all the way to mate it with this surface. So it's going to scrape, create a lot of heat, and then that's how you can have melted parts. Now, keep in mind, if you had this problem where parts melted on your AC compressor clutch, and it wasn't due to a seized AC compressor, but it was due to, let's say, a bearing or an electrical problem that we just talked about, that amount of heat could potentially also damage the seal around your AC compressor shaft. So if this is your problem and then you replace these, you get a new bearing, you need a clutch disc and all that, and your AC works, but then it stops working after a week or two, then just know that that seal could be damaged due to that heat. And the only way to fix this, unfortunately, is going to be either to rebuild your AC compressor or replace it. Also, when that bearing goes, something else can happen is that the coil that's in the back of this pulley can come into contact with the pulley. Here, I can show it to you better with these. These are from a different compressor. Here's the pulley. This is the coil. It's sitting in the back of this pulley, but it's not touching it. But when this bearing that's inside this pulley goes bad, and then this clearance is thrown off, and this comes into contact. These two come into contact with one another. They can scrape up against one another, and then create a lot of heat. That heat will, of course, transfer to the clutch disc, burn your clutch or the rubber parts. Also, it can shorten out this coil, and when you turn on your AC, you could blow a fuse as well. So those are the 3 main culprits that come to my mind on why you would have melted parts on your AC compressor. Now, for those of you that don't know how to do a voltage drop test, leave a comment down below in the comment section and let me know if you want to do a video on that. I think I've done a video on it in the past, maybe 5, 6 years ago. It's probably not the best quality. And also, do me a favor, subscribe. And also, if you're already subscribed, hit that bell notification, because I'm getting comments, people saying they're not notified when my new videos come out. So if you want to do a video on this, make sure you subscribe and hit that bell notification. All right, now on to the next question. So next question is by a subscriber named Mr. Redware. And I'm going to paraphrase. The question asks, we need a practical video in which the AC system only cools at high RPMs or highway speeds, and all cooling fans work fine. All right, so we need to split this question down the middle and see whether your AC system works only when the engine RPM is high and regardless of speed. So in other words, you're parked and your RPM, you step on the gas, the RPM goes up, and that's the only time when you get cold air coming out of your air vents. Or your AC system cools only when you're going 60, 70, 80 miles down on the highway. Because the culprits that would cause this are going to be different. All right, so if your AC system only works when you're traveling at highway speeds, there's a very good chance there's a problem with your AC condenser fans. Now, you said that your fans work, but you got to make sure that both fans work when you're commanding your AC system on. Of course, that's obviously because your AC condenser fans blow over your AC condenser and cool down the refrigerant that's going through it. If they're not working properly, the only time that refrigerant is going to condense and turn into liquid when it's going through your AC condenser is when you're traveling fast at highway speeds, that the wind will get in there and basically do the job of the AC condenser fans. Now, after you verify that both of your fans are working, you should also check for dirt and debris and blockage around your AC condenser and or radiator. And if you see any signs of dirt, or even if you don't, it's a very good idea to always wash and clean your AC condenser and radiator. You'll do wonders for your engine's cooling system and also your AC system if you always regularly clean them. Now, on the other hand, if your AC system only works when the engine RPM is high, in other words, you could be parked, standing still, you put your foot on the gas pedal, raise the engine RPM, and then that's when you get cold air coming out of your air vents. Then the culprits for that scenario are different. For starters, you could be low on refrigerant. Now, to check for low refrigerant, you are going to need one of these guys, which aren't really that expensive. You can get them for $50 on Amazon or even Harbor Freight, or you can get a can of refrigerant with a gauge on it. That will tell you the pressure in the low side of your system. Now, knowing what pressure readings you need to expect on each side of your AC system is going to be based on your car's make and model and the manufacturer specifications. So you need to find your repair manual, look up those numbers, and it's also going to depend on the temperature and the humidity of the outside temperature. Now, I'm going to put a chart on the screen that's going to give you a very, very general idea of what numbers to expect depending on different temperatures and humidity. But again, you need to check your manufacturer's specifications to be precise. All right, so besides low refrigerant in the system, another thing that would cause this is a weak or a bad AC compressor. And you can obviously check this with the AC manifold gauge set, and basically you would have lower than normal numbers on the high pressure side, and the pressure would only rise when you rev the engine to higher RPMs. But if you don't have a gauge set, there's two other ways you can check for this. The first method, as I've mentioned before, is to go find the two pipes that are coming out of your AC compressor. The smaller one is going to be your high pressure side. The bigger one is going to be low pressure side. The high pressure side should be hot or warm to the touch when your AC compressor is engaged and the clutch is engaged and it's spinning. Because it's, as it compresses the refrigerant, it creates a lot of heat. So this one's going to be really hot to the touch. So on this car, for example, our AC compressor is down there. This smaller pipe that hopefully you guys can see is going to be our high pressure side. This bigger one is our low pressure side. So basically you want to get your hand down there and touch that pipe, make sure it's super hot. But again, since it's super hot, it can potentially burn your hand. So make sure you wet your hand or wear a glove or something, or use a laser thermometer to check the temperature. It should be hot, very hot to the touch. Now, another way you can check for a weak or a bad AC compressor is with your engine off, get down there and try to spin your clutch disc, or in other words, try to spin the shaft. If it spins very easily, there should be some resistance to it. As you can see, I'm turning this. I have to use at least some force to turn this. But if you get down there and you can easily spin this, let's say with one finger, and it's just freewheeling, then that means the cylinder bores are more than likely worn out. It's not compressing anything. It's not compressing the refrigerant. It's just freewheeling in there, and therefore it means your AC compressor is bad and needs to be replaced. All right, so hopefully that video helped you guys out and you were able to learn a few things from it. Now, again, if you're not a subscriber, or even if you're a subscriber, make sure you hit that bell notification so you're notified of my next video that will be coming out. And again, let me know if you want in the comment section whether you want me to do a video on voltage drop tests. Also, if you want to see more in-depth videos on how to repair problems with your AC system, I'll put a link to my most recent video that's on here on this side of the screen. There'll be more links in the suggestion box as well. All right, thanks for watching. I'll see you guys next time.